Okay, so here's a quick review of momentum. There are a few questions we can answer that will develop the concept of momentum for us. First question is, of course, what is momentum? Now, there can be a lot of answers, but the answer that we are looking for is first very straightforward one, and that is that momentum is a vector. Okay, that's true. It is a vector. And also, as you see here, I've written momentum as p. That's the generally accepted notation for momentum. And there's an arrow on top that means that momentum is a vector. And a different statement I'm going to write here, that is because there's a physical intuitive way to understand what momentum is, and that is it is a quantity of motion. So if there's motion and if there's a way to quantify motion, it is momentum. So the larger the momentum, the larger is the motion, And as I will write down the formula of momentum, it will be more clear as to why that is true. So what is the formula of momentum? Well, momentum is given by mass, that is scalar, times velocity. Okay, so for example, let's say mass is 1 kilogram and velocity is 5 meters per second in the x cap direction or x direction. That means the momentum will be 1 times 5 x cap, or momentum will be 5 x cap. For the unit of momentum, what you do is unit of momentum will be unit of mass times the unit of velocity. Unit of mass is kilogram, unit of velocity is meters per second. So if we see that the unit of momentum is kilogram meters per second. Now, because this is momentum, you can always resolve momentum into its components. The same way we have resolved forces, the same way you can resolve velocity into its x and y component, the same way you can resolve momentum into its x and y components. So for example, let's say there's a momentum like this, and here you've got y-axis, and that is the x-axis, and let's say this angle is theta. So as we have done, this is going to be the x component of momentum. It is the x component of momentum because it is the shadow of this vector on the x-axis. Okay, the same way this will be the y component, py. Now, if this is p and we have px and py as x and y components, we can figure out those components. So when you do cosine of theta in this triangle, you get px equals to p cosine theta, because cosine of theta is base or adjacent over hypotenuse, and that would mean that cosine of theta will be px over p. So that's why I have written here, like I've just multiplied cosine theta both sides. So if you write cosine theta equals px over p, multiply p both sides, you'll end up with px equals p cosine theta. The same way, if you take sine, you'll see that this will be equal to py. So that's the component. If you really want to write down the formula in terms of velocity, that would be just px equals to p is mv cosine theta, and py will be mv sine theta. And if you remember from the previous discussions, v cosine theta will be actually the x component of velocity, and v sine theta will be y component of velocity. That means you can write this as px as m times x component of velocity, and py as m times y component of velocity.